All right, thanks everyone for coming today. So before we get started, just want to thank you all the sponsors, without whom we wouldn't be here today. And thank you for the staff also to organize this great conference. So who am I, as you said? So I'm Younes. I'm product engineer. I like extreme programming, domain-driven design, and I like to apply it on my day-to-day job. Outside of work, I've been organizing meetups with the DDD Barcelona group. So we organized in the past 2 years talks, workshops, roundtables, basically anything related to domain-driven design or software design in general. And so if you are interested in organizing something in your company or like you have an idea of an event, please don't hesitate to reach out. I would love to help you. All right, so today we're going to talk about living domain model, continuous refactoring to accelerate delivery. So this title might be a bit cryptic, so we're going to try to decrypt it actually together. Starting with refactoring. So I guess we are in Software Crafters Conference. Everyone knows about refactoring. But some of you might also have heard some misconceptions or confusions that come a lot when we talk about refactoring. The first one being, we just finished refactoring the entire service and just released it, right? And so here we might be talking more about a rewrite, not necessarily refactoring. Refactoring is more doing this in small steps, right? Second, also I hear sometimes refactoring this is too risky. We will introduce bugs. Well, actually, refactoring is an activity that should be done under the safety of tests, right? If you're changing code without tests, it's not refactoring, it's just being reckless. Or let's do it right the first time so that we don't need to refactor. Well, this one is tricky, right? I think we can all agree, being in this industry for some time, that the only constant is change, right? Change is inevitable, whether it's technology that changes, our business requirements, or just our understanding that evolves. Our software needs to change, so we should rather optimize for change instead. Another thing I hear, which is a bit difficult to answer, is we don't have time to refactor. And well, actually, if refactoring doesn't make you faster, then don't do it. I mean, the reason why personally I practice refactoring, it's because it's an activity that helps me to deliver faster. And I think I'm going to try to share some stories today that shows that. And finally, let's ask our PO or PM if we can schedule a refactoring sprint. Well, this one comes often, and I think refactoring should be an activity that we do continuously to the point of not even justifying it, right? I agree sometimes we need to do larger refactorings, and in that case, it might be better to do it as part of a business initiative that it supports. And actually, the story of today is about this. All right, so what's refactoring actually? If we look at Martins Fowler official definition, it's a controlled technique for improving the design of an existing code base. What does that mean? So it's about changing structure while keeping the behavior, right? And why is it controlled? It's controlled in the sense that we do small steps in order to reduce the risk of errors, and also we do this with tests, right? The test allows us to be able to change the structure of the code without changing its functionality. And why do we do this? I mean, the purpose of refactoring is actually to improve the design of the code, right? And since change is inevitable, well, refactoring needs to be continuous. And another way you can see it is refactoring is a series of small behavior-preserving transformations, which each one isolated, they don't have so big of an impact, but when you accumulate them, then it leads to larger improvements. All right, next, living domain model. So who here knows what is a domain model? Raise your hand. Okay, who here uses or has put a domain model in production? Yeah, a few hands, cool. All right, so for the ones who don't know what it is, no worries, we're going to explain it a bit. So you can see this as a conceptual model that incorporates both behavior and data. So it's not a database model, right? Because it also adds behavior, and behavior in the sense of this is what makes your application, the feature it has, the business rules, etc. And although it's inspired by reality, a domain model doesn't need to reflect the complexity of reality, right? You just take everything you need and nothing more in order to solve the problem you're focusing on. So domain model, in that sense, it needs to be focused on what you're trying to solve. You can express it in diagrams like UML, in documentation, and eventually in code when it makes sense. And this makes sense especially when you're dealing with a lot of business complexity, I mean high business complexity, which is often the case in core domains. And in object-oriented programming, you could see, for example, a domain model as an object model, while in functional programming, it would be more a set of functions and types. And what makes more concretely a domain model? Well, you can think of it as first core concepts. In the example of an e-commerce system, it could be a basket or a cart, a package, a shipment, right? Or an order. And then these core concepts are linked together by their relationships, right? Coming back to e-commerce, it would be a basket is composed of items, and then whenever we confirm a basket, an order is placed, and an order placed leads to a delivery shipment being issued, these kind of things. And also it contains business rules, right, that regulate how the different concepts are related with one another. So coming back to the basket, it could be we cannot confirm a basket without any item in it, or it could be whenever we have an order of more than 100 euros of goods, then the shipping fee becomes free, right, a discount. That would be a business rule. And so all of those are actually specified and leveraged by what we call the shared language. And that shared language, also called ubiquitous language, the idea of it is that it's the language you speak with everyone involved in the project. So it can be your domain experts, product manager, UX, developers. You try to express all of this model using the same language from the conversations down to the code. So when I open the code, it should reflect the actual conversation we're having with domain experts. All right, so now let's go right into a story. So today I'm going to share a story of a project during which, well, we discovered how continuous refactoring enabled us to accelerate our delivery. Let's start with a bit of context. So it was a few years ago. I just joined a team working on a critical project for the past year. And so that team was great. It was composed of 5 developers that were very knowledgeable and very engaged. And they were working on a service with hexagonal architecture, so far so good, deploying continuously to production, like changes every day. They had a good testing suite, so around 90% coverage. But they had some technical debt that has been started to be introduced because, well, of the past pressure they had to deliver within tight deadlines. So we had some technical debt, and also the code quality could be improved. There were some business logic scattered everywhere across different use cases in the application. So very little domain model, or like a small presence, but not really a rich one. And of course, expectations were quite high, so we needed still to deliver a lot of things. And so let's have a look at the domain. So basically, it was a regulated organization. And so as such, we needed to verify periodically the information of our users, depending on a variety of criteria. So every now and then, we would invite users, sending them communications to verify their information. So they needed to go through different modules to verify part of the information, like their identity, their address, their taxes. And they had to do so before a deadline, a given deadline, after which they would see their accesses being increasingly restricted if they didn't complete it. So that's about it, and we're going to dive a bit deeper. And so after a few months after I joined, we had this massive challenge to actually deliver a lot of features. And as much as we wanted to, these features would involve a lot of refactoring everywhere in the code base, and we couldn't avoid it. And we had to do so, of course, within just a few months. So we were under tight pressure, and we knew we had to do a lot of changes. So how to get started with this, right? So we first started thinking about how can we de-risk that project. And for that, the first thing we went to do is how can we discover really fast what needs to be done, what we need to do in terms of requirements, and how can we collect them and express them in the shortest amount of time. And for this, we used event storming, and more precisely, we used process modeling event storming, which is just a visual collaborative modeling technique where you invite basically everyone that is knowledgeable, domain experts, and every member of the team, and you try to map the new process that you need to design and implement. And based on that, you extract basically all your user story, right? All the things that you need to do. And once we had that, we used also example mapping to actually really deep dive into the more complex stories and we used examples to actually make these business rules emerge. Then, once we knew what we had to do, we had to slice it thin, meaning that we wanted to reduce the scope as much as possible to its bare minimum in order to meet the deadline and reduce the risk. And once we had done that, well, we still needed to execute rapidly, right? Because, okay, we know what we need to do, it's the smallest thing to do, but we still have to do it quite fast. So I'm not going to deep dive more into this because it's not the purpose of the talk, but if you have more questions at the end, I can give more details about that. All right, so now let's move to our journey and let's actually get to the refactoring part, right? So I'm going to share the cues that we've seen and identified in order to know when to refactor, and also the lessons that we learned along the way. And I hope they will be useful to you too. But let's start with an overview of the classes, like when we started to work on this. So we had this hierarchy of classes. At the top, you can see here the verification process class, which is essentially a parent abstract class from which we had first a generic verification process class on the left side, which was abstract too, from which we're inheriting one class per market that we were present in. And these ones were concrete, right? But it was not just this. On the right side, we also had a core verification process. So you see here great naming, by the way, very explicit. And so we were wondering with the team, what's this? So when I arrived, I asked everyone in the team, actually, what is this? And are we actually using it? And they told me, oh yeah, it's from a past project that we had last year. Now it's no longer used. It's no longer relevant. We might just as well delete it. And yeah, and essentially, here we can identify that we had actually 6 concepts, but in the conversations with domain experts, we were only talking about one verification process. So this was already a bit awkward. Why did we have so many concepts in the code, but not really in the conversations? And yeah, that leads us to our first cue. It was that code was actually generating a lot of complexity into our code base. And so we had a lot of if statements like this, where basically if the process is a generic verification process, which was actually the type of classes that were being used, we're doing something, else doing some other thing, but this was not supposed to be called anyway. So we had a lot of if-else with complex casting logic as well, and throwing exception when, it was not one of the 2 types. For example, here we had different functions that were, one was taking the parent class verification process, so basically accepting any type of process. And in other places, we were just accepting the subtype. So yeah, it led to a lot of accidental complexity that we had to deal with. And so how to deal with that? So we wanted to remove that code, right? But since it was everywhere in the code base, we had to deal with a lot of breaking changes. How did we go about this? Well, we started first to analyze our testing suite and remove all the tests that were related to that code, right? That were just testing something that we were no longer using, and made sure to clean them up to have a stable testing suite that we could use throughout our refactoring. And then what we did is to actually use the Mikado technique in ensemble programming. I don't know if you're familiar with the Mikado game. It's basically sticks, and you have to make sure to remove a stick without making the entire pile of stick fall apart, right? And so we use the same technique here, doing this in ensemble programming with the team. And we started with the goal, the end in mind, right? So we started with the goal with the most breaking change of all, like removing the class. And let's see what breaks. So we did that. We did that as part of an investigation, and we identified first a few changes, understanding, okay, if we want to achieve that goal, we need to fix first these 2 changes. And then moving on, identifying more dependencies, and you see like a dependency tree that starts to form. Once we were done with that dependency tree and identifying all the ramifications of the impact of our change, we just reset essentially everything we've done so far. Of course, taking note of the path we went through. And then we started from the very end in mind. So from right to left, making all the change and starting with the last one, basically we identified, and just doing change by change, clearing up the entire dependency tree. And here you notice something important is that we did that under the safety of test, right? So at every single step, we were going from green to green. We were never with breaking changes, right? Because we started with the end of the dependency tree. And so at the end, we end up with the goal, making the desired change actually last. Great, so as a result, we ended up with a fantastic PR with like 7,000 lines of code deleted, right? Usually you would be really, people would scream at you for doing such a PR, but we did that as a group, was okay. And also we deleted dead code. I don't know about you, but I love deleting dead code. It's a passion in life. And so that leads us to our first lesson. Start by cleaning up dead code. Why? Because it helps reducing cognitive load for your team. And usually once you delete dead code, you see much more clearly into your code base. Second, it also reduces liability. That means essentially the maintenance cost, the vulnerability, or also the risk of bugs diminishes with the size of the code base. So do it, but when you do so, be mindful of the following pitfalls. So first, ensure it's not used in production. And here, observability and also running data queries in your database to really identify and understand how your system works is key. Second, do this as much iteratively as possible. And here, for example, Mikado is your friend. Whenever it's too big, you don't see a step forward, just use Mikado and find a way. Also, make sure to have tests. It goes without saying, but it's important to remind. And finally, even when you have tests, be cautious. Make sure to, if you have data, for example, in our case, we had actually some processes that were still pointing towards the old type. So we had to make sure to migrate those users to a newer type of process. So you first migrate the data, then the code in separate deployments to reduce the risk once again. And also in that case, we complemented this with exploratory testing. So the entire team were testing the application just to discover some more unknown unknowns. And finally, when you release it, use feature flags and observability in order to understand when to roll back, when you have an issue, and when you do, roll back easily with feature flags. All right, so now that we have deleted dead code, we could just actually solve our first awkward issue in our model of having so many concepts. And what we did essentially, so we had removed that class, core verification process, and now we could do a merging cascade, so to speak. So we started first to take all these concrete classes. They had a few specifics into each one of them. We just merged that logic and parameterized basically the generic verification process class. And once we had done that, we just merged this one into the first one, right? So to simplify and starting with one concept. And so we ended up with one cohesive class, great. And now our verification process had a type with the parameters that make every market different, and we were in a much better place. And that leads us to a motto for refactoring that I like from Ken Beck, and it drives a lot of my strategy for change. It's whenever you need to make a change, make the change easy, then make the easy change. In our story, and with a caveat, important one, that the first part may be really hard. So in our story, make the change easy was actually deleting all this dead code was quite a difficult activity. It took us quite some time. But in the end, merging all these 6 concepts into one was really simple. It was really I think it took us a day, while the other part maybe 1 week or 2. And so that's something that you can think of whenever making changes, is to think, how can I make this more easy, work on that, and then make the easy change. And so now that we had done so, we wanted to move forward by enriching our domain model, right? Again, coming back to the duplication of logic that we had everywhere in our use cases, we basically had our application service that were not only doing orchestration, but also containing a lot of business logic in them, and we had a very thin domain layer, right? And so the goal of that operation was to actually get back all the logic and move it down to the domain, right? So we moved the business logic down and actually moved it to what we call, in domain-driven design, an aggregate, which is essentially a set of cohesive entities that is here to protect your invariants, your business logic in your domain. And it also acts as a transaction boundary, for example, when you have concurrency conditions. I'm not going to deep dive into detail on how we did that change. There's actually, I will share at the end of the talk, a live coding session from Jimmy Bogert that just does this and explain this. But for here, I want to focus actually on another part, which is we were able to do so because we position our tests here at use case level right? So our tests were covering our hexagon, essentially, which means that anything that happens inside, anything we refactor inside, we could do it without changing our test. And that was really powerful, and it enabled us to really move quickly and being able to refactor a lot of things. And so let's see an example of the two different approaches, right? So a common one that you see often is positioning your unit test at aggregate level, which is great when you have aggregates that are well defined. It leads to a test setup that is actually very easy, right? You just create your aggregate in the state you want, call a public method of your aggregate, and then assert its state, for example. Very easy to do. In our case, though, we were changing our aggregate public methods a lot, and so our domain was moving. So we were much happier with the second version of it, which was positioning the unit test at use case level. And so here you see, even without looking into the details, the setup is more complex, right? So we need to actually have test doubles. You know, for example, for a repository to fetch our aggregate, we need a fake in-memory repository. We need to inject it into our use case, and then we can call our use case here. But first, we need to save a process into our database in the right state, and then calling our use case, and then fetching it from the database and for example, asserting its state, right? So it's a bit more complex, but again, it can help you to refactor actually what's inside, because here we could actually delegate logic to the aggregate. This test will never change. It will remain the same throughout the entire time. Right. So now, once we had moved all this logic down to the domain and to our aggregate, well, we ended up with a class that was becoming bigger and bigger, was harder to understand what was inside, and was actually hard to navigate, and there were some duplication introduced, etc. So we had a class of around 500 lines, and so we wanted to actually solve that problem. So what we did is first, okay, let's go through it. Let's see what's inside. Now that we have grouped everything into this class, let's actually see what's inside. So we had some logic actually related to the process, which seemed fine. And then we could identify some specific logic related to each one of the modules, right? And so what we did is just, well, we split this aggregate into an aggregate with multiple entities, each one with a cohesive behavior, just focused on the module. And it led us to a better separation of concerns between class, and we ended up with a set of smaller cohesive classes. And that leads us to another lesson, which is while you refactor, sometimes you have to make it worse before making it better. What does that mean? In our case, we actually merged, we tried to fetch the logic from everywhere. We put it into our aggregate, which was becoming really ugly. But this allowed us to identify our next move, to actually being able to split it into smaller entities. If we had done just, took the leap to go to the target, it would have been much harder to identify how to structure it. So making it worse first, seeing all the logic inside the class, and then being able to dispatch it to smaller classes was much easier to do. And so in general, when boundaries are unsuitable, just merge everything back together and then try to identify better ones, right? And so in our case, it helped us revealing actually a duplicated logic, and we were able to change our abstractions. Now that we had a much richer, let's say, domain model, we went ahead and starting to add the features that we needed to add, right? So again, we had different types of processes, one per market, and this time we actually needed to introduce a different type of process. This one was focused on whenever a user had a document that was expiring, we needed to ask them to renew their document, to show us their newer document. And so this kind of process had a bit different parameters. The communications, the notifications, and the restrictions were slightly different than the other types of processes. And also some execution logic in the code was actually needed to be different. And so we went ahead and we're thinking, okay, for example, we need to add a third type of restriction. So if you see here, we have like 2 timestamps, which are just recording the date at which we apply a restriction on a process. The first restriction at, second restriction at, and we need to add a third. So here, okay, we could just add a new attribute, right? But then we would fall into the rule of 3, right? So now we start to introduce too much duplication, and we need to deal with it. Second, we also needed to add here actually the logic. So here you can see this function is next restrictions to apply. So as its name states, the goal is to understand what is the restriction to apply for that process at this given time. And so for this, it was a nested switch case. So a bit difficult to understand, right? And depending on the type, and then depending on the number of days since the user was invited, we were applying one restriction or another, right? And so here, again, we needed to add some logic, a condition for the third restriction we wanted to add, which was not ideal. And finally, we had one batch job per restriction type. And so here we needed to add a third one. So you can see here that it doesn't scale quite well. And we can see that something is awkward. We have some duplication. And maybe we're missing a concept here. But what did we do about this? Well, we just went ahead and added. Why? Because it was easy to do and we had some pressure. So we first wanted to get this out of the way. And so we went ahead and actually added it in the easiest way possible. Now, when we had more times, we actually sat down with the team and were thinking, okay, let's come back to that awkwardness. We might be missing concepts here. And so that's when we actually entered in our shared language and in the domain model, two new concepts called restriction schedule and communication schedule. And we actually started to also incorporate that into our conversation with the domain experts. Because even the conversation within the team were becoming quite confusing. We were like, are you talking about the first restriction or the third? I mean, I'm confused. And so that's why we introduced this concept in order to be able to express better, both in the code base and in the conversation, and discuss this restriction. Another thing to mention that is important is we also promoted an attribute of the verification process class. We promoted it to a more important role in our domain. And so this verification type took a bit more importance, and we are going to see how. So after doing that change, it led us to more expressive code. So here you can see on top, remember we had like 3 timestamps. So we were able to actually transform that into a list, so that would scale much better and we would have less duplication. And also the function to determine the next restrictions to apply here, it became much easier. Because now it was actually delegating to the type, that became a much more richer concept. It was delegating to the type the actual responsibility to determine when is the next restriction based on the number of days after invitation for that process. And if we zoom into the type, actually, so it was an enum class on which we introduced a restriction schedule concept. And here we could just express our restriction schedule without introducing duplication. It was very declarative. We could just say, okay, just add this restriction after this number of days after invite. So it was easy to change, actually. We did the same for communications, but for the sake of simplicity, I will just stick to that one. Also, coming back to our batch job, now we could have just one job. So we just merge all the jobs together, and we would just iterate over the type and try to find, over the schedule of the type and try to find the restrictions to apply for each process. Okay, and that leads us to another lesson. So when to refactor? Actually, in many cases, my rule of thumb is make it work, then make it better. But of course, refactor only if it makes you faster to either understand the code, because otherwise it's very hard to change, or make immediate next changes to the code. If it's not allowing you to do that, then you might just as well refactor after, or maybe even later, depending on the importance and context. And in our case, that's just what we did. We went ahead, added all the features we needed to add, because it was not making us any faster to actually refactor first. And after that, when we had more time, we just refactored it based on our new understanding. Now, if you were here this morning at the talk of Mercadona Tech, you would have already heard about this. Who knows here about Chesterton's fence? Yeah, so a few. And okay, I'm going to tell you a bit more about what it is. So let's say we have a fence erected across a road. Okay, we have 2 types of reformers looking at that fence, and by reformers I mean people that are here to improve the system. So for code, it could be two developers looking at a piece of code. And so the more modern type of reformer goes and say, I don't see the use for that barrier. For that fence, let's just clear it away. To which the more intelligent type of reformers answers, I won't let you clear it away if you don't see the use of it. So go away and think, and when you understand why it's there, then I might let you remove it. And so the lesson here, to put it short, is whenever you remove any fence, pause long enough to ask why it was put there in the first place. And this is some piece of advice given to us by Gilbert K. Chesterton. And we learned this the hard way. Who can guess what this number is here? Any guess? Any wild guess?
Users affected?
Yeah, it could be, almost, not that far. And so in our case, we had a fence that we didn't recognize, which was, there was a bad job that was sending communications to customers, and there was a condition in that bad job, in a SQL condition, that was of 10 minutes, that was just sending communication 10 minutes ahead of schedule. So we were wondering, why 10 minutes before the actual time we need to send it? So I asked around, we asked each other in the team, we're like, why is this there? Oh yeah, I don't think it's any useful, we can just remove it. So we went ahead, removed it, released to production, everything was fine, no alert, nothing. We came back the next day to work, looking at our metrics dashboard, and then we see a very, very high number of communications being sent. And actually, over the course of 23 hours, we sent 289,634 duplicate communications to customer in just 23 hours. So of course, we just immediately rolled back, and that's when we understand that recognize your fences and actually try to understand them before removing them. Another lesson we can take away from this is that we introduced that change as part of a larger refactoring. And so instead of just focusing on changing the structure, we're a bit too ambitious and said, okay, let's just remove that piece of behavior, it's fine. And so inside the larger refactoring, it was harder to identify how we broke something, because there was this small change included, this small change of behavior. And so that leads to the lesson I want you to take away. Separate structural changes from behavioral changes. Never do both at once. If you realize while doing a behavior change that you need to change a structure, then just pause, revert, do the structure change, make change easy, right? And then make the easy change. Now, our final cue for today, when actually refactoring the communications logic, we also realized that we had some domain logic leaking into an adapter. And so here you can see on the left side, let's say it's a use case that was just, as part of its logic, it's sending communications to a customer. And to do so, it just passes a verification process as an argument. So far, so good. But then you move on to the implementation of that gateway, like let's say an email communications gateway, and you see somewhere in the code some complex domain logic there to calculate some attributes, etc. And we needed to make some changes to that class, but there we were like not very confident because it was really hard to change and understand what it was doing. Here's just an example, but we had a logic like this in different places. So we decided to actually fix it. And for that, we used a technique that is quite powerful, that is called expand and contract, also known as parallel change. And so the idea is we're not satisfied with the current interface we've been given that takes, a process as a parameter and actually leaks domain logic into the adapter. So let's do something else and actually create a new interface that we call, called send communication. But here the trick is it takes a different parameter, communication request, which is just a DTO, right? So it contains exactly the logic you need to put in a communication template that you can just send. And so with this, we had implemented this new interface in the adapter, and it was free of any domain logic, so it was an implementation we're happy to live with. Well, now we needed to migrate all the users of that old function, right? So we went ahead, identified all the use cases that were actually sending communications. So we had 3, like when we invite the users, all the reminders we need to send to them. And of course, when we apply restrictions, we need to communicate to them. And so we went ahead and migrated them one by one, every use case. So the power of that technique is you can actually do this very much iteratively. And we just went ahead, migrate one use case, release, migrate another use case until we end up with all the use cases using the new port, the new interface. And now we can just retire the old one. And we can just delete it along with its implementation. And that's what we did. And yay, we were able to release in time. And thanks to a lot of continuous refactoring, actually. So now, let's wrap up. I want you to leave with maybe a summary that I tried to compile of all the concepts and all we've been seeing. And for that, I don't know if you're familiar with causal loops diagram. Anyone? Yeah? Okay, I'm going to try to explain how to read this. So it's basically a concept that has been popular, it exists for a long time, but it has been popularized recently in system thinking community. And so the idea is to express different variables. So those are the bubbles you see there, are variables. And then trying to express the relationships, the interconnection between those variables and how they influence one another. So let's take an example here. Test suite strength influences refactoring, right? And how to read that plus is the higher the test suite strength, the more we do refactoring, yeah? The other way around would be the lower test suite strength, the less refactoring we do, because the less tests we have, the less coverage, the less we can refactor, all right? Let's take an example. Let's start with a small one. So here, starting at the top, the less code complexity we have, the more we can refactor. So minus means it evolves the other way around. So the less complexity, the more we refactor, and the more we refactor, the less complex the code usually becomes, right? We can also, so in that case, it's a virtuous cycle, and here we call that a reinforcing feedback loop, because it goes and here it's a virtuous cycle if you go that way. The other way around, the more complex the code, the less refactoring we do usually because the harder it is. So we need to be mindful also of that dynamic. Now let's move on to a more complex one, which is actually a bit the summary. Refactoring enables us to deliver business value faster. And let's start with refactoring, actually. The more refactoring we do, the fitter our model. And what does that mean? It's the more our model is fit, the more it is suitable to solve the problems we're trying to solve, right? So the more refactoring usually leads to a better model to solve better our problem. And then the more the model is fit, the faster we go in our delivery. The faster we go, the more features we deliver. The more features we deliver, if discovery is done right, the more business value we deliver also. And the more business value we deliver, the more useful our system so that we can keep refactoring it again. And so here again, it's a reinforcing feedback loop that makes refactoring enabling us to deliver faster, business value faster. But it doesn't grow exponentially, right? Usually when you see a reinforcing loop, there are some hidden balancing loops that make the system stable. And in that case, we have two here. The first one is that the more our model is fit, the faster we deliver. The faster we deliver, the more features we add. But usually the more features we add, the more we stress our model. And so the more our model becomes harder to manage, and we need to spend some more time to work on it, right? So it's slowing us down as well. And so adding features can stress the model and slow us down. But it's not like we need to refactor until the end of time, right? Anyway, because here we can see that the more we refactor, the fitter is our model, and the less we need to refactor actually. So it's not like we need to refactor endlessly, we stop when it's good enough. Now finally, two things that are quite foundational for that are the test suite strength is actually influencing refactoring highly positively, and the other way around, if we don't have tests, we cannot refactor. The same way, if we don't have good domain knowledge, if we don't insist on really spending the time to understand our domain, we cannot design a good model. So we'll never be able to have a model that is fit and able to solve our problems. So they're both foundational to fast-paced delivery. And that's about it. To dive deeper, I would suggest to have a look at these resources. So the first one is about Design and Reality. It's a book by Rebecca Reeves-Brock and Matthias Verais, and they give real-life examples about domain models and how they refine them, how they do the knowledge crunching and understanding when this model is no longer fit and how to improve it. Then you have, of course, the Refactoring Bible by Martin Fowler, where you see a lot of code smells and how to deal with them. Then a good book also by Ken Beck is Tidy First, which actually tries also to answer that question about when should I refactor? Should I refactor before or after? And it gives quite good examples on how to deal with that. And finally, the talk I mentioned from Jimmy Bogert that just shows how to refactor logic from your use case down to a domain model. And that's it. Thank you very much for your attention.
What was the hardest part in all this process?
That's a good question. I think, to be honest, I think it would be the beginning to really understand the scope of changes and how big it was. That was actually something that took us some time. So like doing the event storming, trying to understand and trying to come up with a good understanding of all the changes that we needed to do and how to get started was a bit difficult. But I think what made it easier is that we were really taking it step by step. We're not trying to guess too much in advance where to go. And we're actually in the present moment trying to think, okay, now what can we do? And one thing that helped us a lot, I did not go into details, was we're always trying to kind of work in a dual track where we identify what we need to work on next. For example, the communication schedule, the communication, making changes there. And one developer in the team or like a pair of developers would actually, before making that change, they would focus on refactoring to enable faster change after. So we had this kind of dual track in a sense, where we were trying to think just about the next step. So there were people working on the current step and people preparing the next, if that makes sense.
You had a deadline and you decided to start refactoring. Did you have any conversation with business, or it was something on your own? You didn't have to tell nothing to the business, or you had a conversation with the business, and what was it, or how did you handle that situation?
So it was a bit tricky because in our case, in our case, when I arrived and I joined that team, this deadline was already set and has been agreed upon with important people. So we could not challenge the deadline. So that was something we've been told straight from the beginning, talking with stakeholders, they told us this is not negotiable. So instead of trying to change that deadline, we really focused on, okay, what's the smallest thing we can do? Because we can't change the date, but we can change the scope. So we did a lot of persuasion to try to tell them, hey, actually this is not necessary, maybe we can do that. For example, there were some parts of the user experience that we could have improved, but we decided to take some shortcuts actually and reuse most of what we had instead of trying to make it too complex in order to really reduce the scope of changes. And I would say we focused more the conversations on the scope rather than on the deadline.
Do you have friction because with some developers to do the continuous refactoring, because some developers they see not this one maybe because the goal was a specific goal, but I think you are advocate of continuous refactoring. I mean that sometimes some developers they feel that is fracaso, how do you say fracaso? Failure. Yeah, a failure to do the refactoring. Mm-hmm. And how, if you have any friction with that, because they say, oh, we didn't think, or we didn't, and then instead to do refactor, they do a bigger waterfall. You know, instead of in this diagram with loops, they do the opposite. They start to do a waterfall.
Yes, absolutely. So we had some reluctant developers in the team also, that when we were, when I was suggesting, hey, let's go ahead and refactor it. If it's dead code, let's just remove it. we had, so actually the example of the sentences you heard at first, like some of them were coming from my team actually. Like, it's too risky, we'll introduce bugs, and actually we did, so I shared like one example. But I think by actually showing a first example and trying to get the team buy-in to just try, and starting with the first refactoring, we started to get some more buy-in from everyone in the team. Like when they saw that it was actually making us faster, people really start to engage in that activity and they really started to buy into it. But first, the first time, I think it's a lot about, hey, let's try as a team, and you need to show like that it works on one concrete example instead of just arguing too much. Just try the smallest you can do and show the benefits already. And I think that's what helped me and my team like actually have the buy-in from everyone and by showing the benefits first. I don't know if that answers, yeah?
Okay. How do you, and maybe you cannot measure it, but do you have a way in your team or in the company to measure that you are going faster? Or it was just a feeling of, okay, now we don't have so many problems and it's a feeling, or it was something that you were doing in some way?
That's a very good question. I would say, personally, I'm not gonna lie, I would say it's more of a feeling in the sense that sometimes, I mean, of course, for simplicity and brevity, I did not go into everything, but sometimes we try not to refactor. And so some things we actually went ahead and tried to add the change, and after like 2 days of work, we're like, no, this is not gonna work. So we need to stop there and, you know, we roll back and we find a better way. And whenever we did so, like we realized, oh, now by refactoring, including the refactoring, we're much faster to make the change. So I think it's more by empirical evidence that led us to believe we're going faster, because when we tried to do a different way, like we would really experience that we were going much slower or running into dead ends, like when, you know, you're not able to make the change and you have a lot of complexity starts to increase and the team is not comfortable with that, yeah.